Full slide.
Yeah, please go ahead, sir.
Okay. Thank you, Raju sir and Ravi Kishore sir, and dear faculty members. So, nanotechnology for sustainable manufacturing. We are all familiar. As a teacher of engineering colleges, we know something about sustainable manufacturing, sustainable development of a nation, sustainable development of an industry. Even though efforts made by the UNO, United Nations Organization for Sustainable Development of any nation, in all the industries, but it is not 100% being implemented. So, nanotechnology may not 100% replace these things, but a portion of the sustainable development of the nation, society can be possible. Even the biosphere, the environment can also be become peaceful, sustainable with the technology going on. So on this aspect, my topic is nanotechnology for sustainable manufacturing applied in agricultural industry, a case study. As you see in this top slide itself, the first picture shows the soil. The next one is producing some nanocellulose using water from green synthesis techniques using the plants, herbal products, leaves and others, roots. The olden days agriculture using the plow and the animals, cow, bull, where the fertility of the soil was not destroyed very much. So the presentation includes some few slides, a glimpse on sustainable manufacturing, because when we know brief thing about sustainable manufacturing, then it is easy to understand how this can be obtained with the technology that is going on. And sustainability in agriculture, as we see, agriculture today, the farmers are the only people working rigorously without any expecting anything from the society. They are feeding us, but the crop yield on a regular basis, even not the profit, but crop yield on regular basis, whether it can be a food crop, commercial crops or fruits or vegetable crops, whatever it may be, it is not happening because of various climatic conditions. Our behavior also one of the reason for making the environment angry. We are seeing the floods going on, the natural calamities going on in China and other countries. So this is all the mistake made by us. The way we are living together with the earth, eco-friendly manner, the society, the nature, the biodiversity, making all these things behaving in a vulnerable manner. So the sustainability in agriculture, how it is possible to maintain agricultural sustainability. Green nanotechnology, as you have seen so many speakers earlier, nanoparticles, how nanoparticles can be produced from the nature using the leaves, the barks, the roots from the plants and herbal products. So that comes under green nanotechnology. Nanotechnology for sustainable agriculture, how nanopesticides like nano urea, nano gold, and how the advanced technology can be used in the agricultural sector for its sustainable development. As we see today, agriculture has become an industry. Olden days, even today, many people think that agriculture means only farming. That is a farmer with his limited tools and equipment, and for his family purpose or additional to the family purpose he will produce. But today agriculture has become industry. It's not only plantation, the livestock, the equipment used in the agriculture, right from the plantation, seeding, and this cultivation and irrigation and crop cutting, crop crushing, crop storing. So we have so many equipment, the automated guided vehicles, advanced equipment we are using even for cutting the fruits and flower plucking and all these things. So therefore, the nanotechnology for sustainable agriculture is indicating that agriculture today has become an industry. It's not only farming, the livestock and other equipment also. Then precision agriculture in advanced, I cannot say they are advanced countries, but they are using advanced technology. Some of the countries like Malaysia and other countries, they are using even some of the areas in India also, this GPS, global positioning system, GIS, advanced drones for the agricultural and farming and plantation purpose. And finally, conclusion. So these are the presentation topics. So I'll finish within time only. So let us see, first of all, what is sustainability. Nature as a whole fixes about 110 to 120 billion tons of carbon per annum through photosynthesis process. We human emit only 0.65 billion tons of carbon dioxide through respiration process, as you see here. But carbon emissions due to human activity constitute about 8 billion tons. That is 77.5% of which is due to the burning of fossil fuels alone. We are all familiar with this, the COVID-19. Now we are telling that this is a second part, COVID, but in the first time when it has come, after it has given certain relaxation, we have seen that the climatic condition has become very cool because due to lockdown period, all the vehicles stopped, the factories stopped working, and that made using of the fossil fuels in less consumption, less quantity, and environmental pollution, pollutants, CO, CO2, and other sulfur, sulfuric acid, and other contaminants released into the atmosphere is also less. Because the entire world has stopped at a time for a very large amount of period. That made the environment, the nature, the climate regaining. We have seen in televisions also about 11 to 12% of greenery has been the green condition, the greenery, the health of the nature has recovered because of lockdown period. Of course, we humans suffered a lot because of lockdown and other the corona situation, but nature was very happy because the pollutants released to atmosphere has been reduced. And fossil fuels burning and also release so much amount of the pollutants. So that is making the environment. We are not separate from the environment. We are not separate from the nature. We are not separate from the Mother Earth. So we are all together. The technology made all the nations together as a single family. Even in India also, in this program also, we have very good number of participants throughout the nation. Luckily, we have from all the states and with very good cooperation. So thanks to technology, this online mode technology, GPS technology, Google Meet technology, Zoom technology, internet technology, this made us on one side has become a single family, but on the other side, sustainability in various industries, not only agricultural, automobile industry, manufacturing sector, and the other areas also, as sustainability has become one problem. So during this process, we produce a lot of other waste such as smoke, complex organic compounds, and oxides of nitrogen. I think some of the seniors who are participating in the program might be aware of this sustainability, but many of the young faculty are there. That's why I would like to introduce some concepts about sustainability. And obviously, the technologies we have developed are much less efficient than those operating in nature. Let us stick to this. After 1.5 years of the corona only, we have produced a vaccine. But people are telling that even this vaccine is not working 100%. That technology can create so many gadgets, can create so many medicines, many things, but it can make the people comfort but not happy. Happiness is in our hands. Technology can produce so many goods, even robots and all these things. It will produce so many goods and equipments and gadgets that makes us comfortable. But comfortability does not make the man happy, healthy, and all these things. So therefore, the technology what we have developed so far, including nanotechnology also, that is not making the human being happy, healthy, and all these things. On one side, we are developing the technology. On the other side, we are doing certain harm to the nature, environment, etc. The most importantly, the benefits accruing from this process and machines developed by us are incongruent with huge amounts of resources we utilize for these developments. Some of the concepts of sustainability and sustainable manufacturing. So in manufacturing sector, as we are talking about Industry 4 and smart manufacturing. So the manufacturing, the sustainable manufacture is also very essential, because manufacturing industry is the backbone of development of any nation. Again, in this agriculture sector, agricultural industry is the main contributor in the development, even feeding the entire society or population. So in last 50 years, humans have consumed more resources than in all the previous history. If you see, before independence, some few hundred years back, we were not having this much amount of water facilities for the domestic purpose. Today we have 10 taps in our home and one overhead tank to preserve water, but still we are not happy and we are not getting pure water. In olden days, people were walking for 10 miles with a simple pot for getting drinking water, and they were happy. They used to take bath in nearby tanks and rivers, but still people were happy. Of course, medicine and this field was not developed that much. But the way we are consuming the natural resources, the water, the other resources, the wood, plants and trees which we cut for our domestic purpose and all these things, the construction area, the resources which we are using is more than which we are creating again. So in total, 60 billion tons of resources are extracted annually, which is 50% more than just 30 years ago. So in the last 30 years, they are consuming more of the resources. As much fresh water has been withdrawn in last 30 years as in the last 3 centuries. Now you see in metropolitan cities, in Chennai, Hyderabad and other, getting pure drinking water is very, very difficult, because water has to go to thousands of miles of hundreds or even 10 to 20 miles or 50 miles of distance. It has to go through the pipelines, and during this travel, a lot of amount of contaminants are happening. Between 1950 to 2005, worldwide metals production grew by 6 times, oil consumption 8 times, and natural gas consumption 14 times, against the population grew by 2.2 times. So therefore, the sustainable manufacturing is the creation of manufactured products through economically sound process. We need today the process which we need. Yesterday we have seen some nano finishing technologies. So we need today the technologies and machinery process that will minimize the negative environmental impacts while conserving energy and natural resources. We are all know mechanical engineers, the efficiency of the IC engines, hardly 40 to 30 to 50, less than 40 or less than 50. So fuel is consumed for the working, for maintenance of the engine itself, and even for other machinery also. So preserving the resources is one of the main concept in the sustainable manufacturing. So it also enhances employee, community and product safety. These are the 3 basics of, I put the 3 to some 5 slides about the sustainability. So these are the 3 pillars of sustainability. Any industry, a nation or even the globe will have all the sustainable factors. There are about 20 to 26 factors are given by the Sustainable Development Organization at the worldwide. But all those factors are coming under these 3 main pillars. That is a social pillar, environmental, economic. Now, of course, the zone, the area of the environmental pillar is more when compared to the society and economy. The society and economic are public also part of the environment, biosphere. We people and the profit, economic growth, development, all these are part of the biosphere. So therefore, the environmental pillar is the scope of environmental pillar is more. And what the governments, every government, every nation is doing, they are concentrating on only one part at any time. Recently, you have seen the Kenya government, few years back, they have concentrated on this, what is that called, environmental pillar. That is for the protection of the animals in the forest, wild animals and other animals. They have taken one initiative to protect them, to preserve them, and they have invited so many tourist places, tourists to the forest, such that that also their aim also to grow economically. But ultimately, what happened? Many of us know. The animals started increasing their population, and they started attacking on the local hill region people, local farmers, and killing them. So that made again the third pillar has come down. So thus concentrating only one pillar made the two pillars come down. So that is the integrity. Integrity of these three pillars is very essential for the sustainable development as a whole. We are all know the GDP, that is gross domestic product, indicating the financial measure of any nation from the people's point of view, products point of view, the productivity point of view. But GDP is only aligning with these other factors. But the America recently, United Nations also agreed that there is inequality in the economical point of view. When we concentrate only on any one pillar at a time, either profit based or economic based or environmental based or societal based, neglecting the other two at the cost of the other two, the sustainability will never possible. So that is how the integration of all these three, the societal factors, health, proper food availability, and good hygienic food availability, health conditions, pure water availability, and good residence facilities, and all these things, pure water, and all these things comes under societal factor. Environmental conditions, proper raining, timely raining conditions, temperature conditions, natural calamities avoiding, and other at the same time economic growth. So when all these conditions, all these pillars are equally integrated, equally developed, then any nation or any industry will develop, will have 100% fruits of this sustainability. As the sustainability is most often defined as meeting the needs of the present without compromising the ability of future generations to meet theirs. So it has three main pillars, that is economic, environmental, and social. And when it comes to manufacturing, what is meant by sustainable manufacturing? We know manufacturing indicating in our mechanical engineering laboratories, it can be used of the metal cutting equipment, lathe machine, drilling machine, and others. Similarly, production technology laboratories, and what is going on in the industry, that is welding industry, with the various trades. So mechanical, physical, and chemical process to modify the geometry, properties, and appearance of a given starting material is nothing but the manufacturing. But what is meant by sustainable manufacturing? So whatever the products which we create and the process which we are using for creating these things, that must be non-polluting. So if you see the lathe machine or other industry, even the welding process which we also see, the gas welding, others. So the manufacturing process which we use, they must be non-polluting, conserve energy, and less consumption of natural resources, and are economically sound, and must be the safety for the employees, communities, and consumers. And one thing I would like to remember, the technologies, of course, we are developing very good technologies, but we must see the safeguard, the health, the comfort, the hygiene of the human being also. If you take the farmers' cases, advanced fertilizers are coming, nano fertilizers are coming, advanced pesticides are coming. But whether these will increases the safeguard health of the farmers, that we have to consider. Not only the yield point of view, we have to consider these things also. So manufacturing is the most resource intensive process of all human activities. These are the certain numericals. The sustainable manufacturing process are those which generate minimum quantity of waste. So this is one thing. Sustainable manufacturing is indicated when we have the minimum quantity of the waste. Waste must be recycled. Already some of the speakers have told 6 R's: reuse, recycle, remanufacture, redesign. So demonstrating the improved environmental performance and energy efficiency while providing operational safety and personal health. Thus, sustainable manufacturing is a branch of sustainability dealing with economical, environmental, and social objectives of the manufacturing activities. And these are the 6 sustainable criteria as we see here. That is manufacturing cost, energy consumption, waste management. So the manufacturing cost must be very less, energy consumption must be less, and we must have the more awareness on the this waste management. So today we are seeing so much amount of plastic disposal, metals scrap, and other wood scrap, and other materials, and recycling of all these things. So when we have the the technology and awareness of how to cut down the consumption of the waste from the factory, from the industry, or even from the domestic area, and how to recycle it. So that is, we must have the awareness on the waste management, and operational safety must be more. Safety of the farmer, safety of the human, safety of the workers, and personal health and hygienic conditions must be improved. Environmental impact, that is, ultimately, we do, we are responsible what are the nature is doing today to the humanity. Even corona is also due to it is our mistake, not in the sense our in the sense maybe some human being, but ultimately what we eat, what we drink, how to live, how we live, all these things matters. Ultimately, as we know, for every action there is an equal and opposite reaction. How we live with the nature, the way the nature also reacts. So that is, environment is also having impact. So this is what we call 6 sustainable criteria, and the sustainability in any industry is evaluated by these factors. So operational safety involving exposure to the corrosive or toxic chemicals not only consider always the profit of any industry, output of the industry, tonnage of the industry, yield of any industry, but these things are very essential. Personal health point of view also, chemical contamination, working environment, and waste management, mass of disposed consumables, reuse ratio, mass of mist generation, mass of disposed chips, etc. These are the other indicators whether we have reached to sustainability or not. Any industry is evaluated when we reach to these particular factors. By evaluating these things, we can say whether we are reached to the sustainability or not. Labor cost, consumable, cost of energy, maintenance cost of product treatment, energy consumption, and environmental impact. And nowadays, we see as teachers of the engineering colleges, we're all come across all these common terms. They are almost representing 70 to 80%. The content is similarity: green manufacturing, clean manufacturing, environmental conscious manufacturing, environmental benign manufacturing, environmentally responsible manufacturing, eco-friendly manufacturing, sustainable manufacturing, etc. So all these are actually their meaning is same, but we are using in a different perspective. But 10 to 20% is different, but rest of the things are similar. Now, this is what we see: this evolution of the sustainable manufacturing, right from the traditional manufacturing where it is a substitution based, lean manufacturing involving waste reduction, and green manufacturing purely environmental benign and involving any 3 R's out of these: reduce, reuse, recycle, recover, redesign, remanufacture, and sustainable manufacturing involving all these 6 R's. Now, in practice, when it comes to in reality, so the sustainable manufacturing is using renewable materials that don't deplete the nature environment, using fewer materials, inputs, materials that are non-hazardous, modifying production systems, production process, using less energy, water and materials, shifting to non-renewable energy sources, using less packaging. We see we are unable to implement 100% of these plastic usages. So using lowering product weight, using more efficient transportation, and all these things. Designing the product to be reusable, remanufacturable, recyclable, and biodegradable. Expanding the life of the product, making it easier to repair or design. These are the implementation of the sustainable manufacturing points by proper housekeeping, improvement in work practices. Now you see some of the metropolitan cities, in municipalities, they are putting the separate dustbins for the dry dust and the wet dust. So in Telugu we call it as Tadi Chetta and Podi Chetta. In Guntur district, Guntur city, the government is implementing strictly to put 2 dustbins for these things so that they can be separated. So the waste which we throw should not be mixed. Process optimization, raw material substitution, new technologies, new product designs. Now the other topic is the green nanotechnology. So that I finished a few topics about the sustainability. Then what is meant by green nanotechnology? The name green indicating that whatever we produce with the help of the nature, what we think, what we take, what we observe, what we absorb from the nature and making use of them to produce these things. We all know from the thousands of years in Ayurveda, nano gold was used for treatment of cancer, nano silver and nano gold. Even Indians are also very familiar with this technology, particulate gold, particle form of the gold is used in treatment of cancer. Teachers who are familiar with this nanotechnology subject, they might be knowing this, some textbooks. So this green nanotechnology corresponds to the applications of nanotechnology for enhancement of the environmental sustainability, a process causing adverse effects on the environment. This process of green nanotechnology includes production of green nanoproducts, that is making use of the products from the nature, that is using the soil, using the plants and the trees, herbal products, etc. Using these herbs, green trees and plants, we will produce certain nano products or nanoparticles. We can see certain visuals later that nanoparticles are produced using the plants, trees and the herbal products. And even see this nano turmeric, today it has become very famous. Some yoga gurus are also telling that consuming nano turmeric with the neem leaves and making them as a paste balls, and if you consume that, that will treat cancer in a wonderful manner. Even science also telling that, medical proven these results are also there when you consume the turmeric, that improve the human immunity. So that applications of these novel nano products in establishment of sustainability. Thus, green nanotechnology is defined as the development of clean technologies for minimizing potential human health and environmental risk associated with the manufacture and application of nano products. The global warming, we are all familiar with these things. The repeated intensive farming, today we see very less number of farmers are using the olden days agricultural farming techniques. Bulls are using the bulls and plow is almost reduced. Now, where intensive farming using this technology, machinery is reducing the fertility of the soil. When the fertility of the soil is reduced, whatever we add from outside, externally in the form of even nano fertilizers or whatever it may be, when source is lost, when base is lost, it's of nothing, it's of no benefit of adding anything from the outside. That is how ultimately the environment, the globe on which we are living, the biosphere, it must be health and happy. This is only possible proper maintenance of the other two pillars, that is the society and the economical point of view. This green nanotechnology is involving eco-friendly manufacturing of those products, processes, not compromising with the sustainability, and socially applicable products produced by using this green nanotechnology and cost-effective products. Now, today, farmers are expressing. At the end, I think if time permits, I will show some of the farmers. Of course, in all the states of India, also are using nano fertilizers and nano pesticides. They are expressing their happiness. These nano fertilizers are available at less cost, but with more yield. But the adverse effects, the negative effects of using these things must be scientifically to be investigated. These are the main focus areas of green nanotechnology. So less energy consumption during the nano manufacturing, replacing the existing materials with environmental friendly materials. So whatever the products which we make, they must be environmentally friendly. We are neglecting the environment, we are neglecting the nature, we are neglecting the globe. The Mother Earth is suffering with the technologies what we are developing. Of course, technology is, no doubt it is needed for the happiness, comfort and of the human being. At the same time, we are cutting the tree on which we are sitting. Ultimately, we will fall down. The corona is giving a good lesson. The floods happening in China is making one more lesson. China, due to extensive inclination towards the economic pillar, neglecting the environmental pillar and societal pillar, on more profit oriented, increasing the rapid development of the industries, so many products, so many electronic gadgets, China mobiles, everything, they are releasing so many number of products, keeping in view of the third pillar, that is economic point of view. But we know what is happening in China today. Due to rapid industrialization, the nature is suffering much, and in the form of floods and other natural calamities, we are suffering. That is, whatever we produce can be technology, process, material. It must be environmentally friendly. Ability to recycle the material after the application. So green nanotechnology also involves. We are all familiar with the homeo medicine, which are very, very small balls, but we know that it is the powerful medicine. Because of reduction in the size, the more power is concentrated in the small. That is the beauty of the nanotechnology. And as the name indicating, nano 10 power minus 9 meters. So when the power size is reducing due to high surface area, the surface reactivity, the benefits, the applications are wonderful. I don't like to go to the fundamentals of nanotechnology. Many of us are known. So due to increased surface area of the nanoparticles, nanomaterials, nano products, nano gadgets, carbon nanotubes, they are behaving in wonderful manner. And ultimately, the green nano also focuses on solution of present environmental problems. These are some of the advantages and disadvantages of the green nanosynthesis. So non-toxic, environmental friendly, non-expensive equipment, cost-effective, easy synthesis, and room temperature easy to scale up. But some of the disadvantages, limitations of this green nanosynthesis or green synthesis using from the nature and products available from the nature and the earth is reproducibility may not be possible, and of course some time consuming. Whatever the conventional processing, yesterday I have seen nano finishing process, and other using the nanoparticles produced by sputtering process, physical vapor deposition, chemical vapor deposition. All these things may not be adaptable for green synthesis. This is the general methodology of green synthesis, mostly the plant-based synthesis you see here. So we can produce certain nanomaterials and nanoparticles, nano layers, nano coatings, where you can see this picture. This is the structure of the material, nanomaterial produced, obtained with the microscopes. Now we take the extracts from the plants. We make the juices, we crush them, we grind them and make these juices, and again refining and purifying those juices, and we go for a mechanical stirring of them, and we go for purification, and by finally filtering and other chemical synthesis process. So we get the required nanomaterials or nano products. So that is how, this is one simple example how plant extracts can be used to produce some nanomaterials or nano products. We are all familiar with one plant, that is aloe vera. We used to grow in our homes, and the nanoparticles, the indium oxide, In2O3. I hope you are seeing this slide clearly. Otherwise, I can show later. I can give this. So aloe vera can be used to produce indium oxide nanoparticles of size of some 5 to 50 nanometers. No, aloe vera is good, applicable in skin diseases, in what is that called, in beautification and treatment of other allergy and other all these things, and facial these things, aloe vera is best suitable. So it is already using to produce indium oxides of approximately 5 to 50 nanometers of spherical shape, and the part which we use in aloe vera is the leaves. Aloe vera leaves can be used to produce indium oxide nanoparticles. Similarly, you can see many other scientific plants in their scientific names. That is Acalypha indica and A. mexicana and Artemisia nigricea. So where silver nanoparticles are produced, and similarly other silver nanoparticles, gold nanoparticles from Mentha piperita, where you can produce some gold nanoparticles. There was literature evidence, and even some few grams of few very very less amount of gold also possible from the human being body, because human being body also contains so many minerals, metals and all these things. Even DNA contains these carbon, oxygen and nitrogen, the main elements. And this explains the plant-mediated synthesis of silver nanoparticles. Now see the barks, leaves, seeds, fruits, flowers, and peels. All these things obtained from the plants are used for producing the nanoparticles. And some of these nanoparticles are gold nanoparticles, copper nanoparticles, zinc oxide nanoparticles. These days, these are used. Zinc is used in the agricultural sector. Cerium oxide, iron oxide, and titanium oxide. And green synthesized nanomaterials, and some of the applications are the nanomaterials, nanoparticles obtained from this green nanotechnology can be used in drug delivery, biosensors, antibacterial, anti-cancer. Zinc oxide can be used for photocatalysis. Indium oxide can be used as the nanosensors, iron oxide for remediation, and similar palladium, platinum, copper for antimicrobial, and manganese oxide for wastewater treatment, titanium oxide for cosmetics and others, etc. The other point of my presentation is sustainable agriculture. Agricultural sustainability is very, very important. Agriculture is the main, even whatever we eat today, it is all because of the agricultural sector only, agricultural industry only. It is the boon given by the farmers to us. It is their contribution made us to live, to eat, all these things. But we need the proper sustainability in agriculture also. So this agricultural sustainability is defined as an integrated system of plant and animal production practices, that is livestock. The cattle population we see, how much amount of cattle population is available when compared with some 100 years back. We are cutting recklessly all these cow, bulls and all these things. We are rarely seeing the cows today. The cattle population is reducing in a rapid manner. We are making our own mistakes. So this also comes under agricultural industry, the livestock, the animal production, the plant production, and integration of all these things. Earlier days, with the help of the animals, plow, farmer, and the rains were promptly falling in time. What is the required amount of rain? That is also falling. That made the nature happy and human being is also happy. But today, the things have been completely changed. The sustainable agricultural in long term should satisfy the human food and fiber needs, enhancement environmental quality and the natural resource base upon which the agricultural economy depends. Oh, people today we are producing the rice and other products, but most of them are missing the fibers. This also need to be considered. Of course, alternative food is available for rice. So make the most efficient use of non-renewable resources and on farm resources and integrate where appropriate natural biological cycles and controls. Sustain the economic viability of farm operators. Enhance the quality of the life for farmers and society as a whole. So that is what is the necessity of the sustainability in agriculture. You see the beautiful picture here, traditional farming methods where the farmer, nature, and the livestock or the cattle or animals are involved in the farming process. These are some of the factors that affects the agricultural sustainability. One is climate, soil, nutrients, a sufficient amount of nitrogen, phosphorus, zinc. We all know that in the form of fertilizers we are using for the agricultural farming purposes. Proper nutrients available for the soil, because of intensive use. Of course, we are changing the crop, but that will not ultimate 100% replaces. Regeneration is not possible. Proper nutrient supply from the outside. So water resources, and out of these climate, soil, nutrients, and water resources, water and soil conservation are most amenable to human intervention. Water and soil. We cannot replace the soil, whatever that has come from the nature by the artificial things. And we cannot produce no water, pure water like the coconut water. Nature has given wonderful fruits to us. Nature has given wonderful gifts to us, but we are spoiling them. So the nanotechnology for sustainability in agricultural, right from the seed to the harvest, Today we are using right from the beginning of the farming to the ultimately crop yielding, crop cutting, crop yielding, not only in simple farming process, in plantation also, in growing the gardening, trees, and vegetable plantation, fruits, and all these things. These things are the nanotechnologies in the form of fertilizers, pesticides, and other nanoparticles in various areas of the plants and trees, right from the roots, branches, branches, and various parts of the trees and plants are also individually nanotechnology can be announced. We know today drug delivery, that is a targeted drug delivery. Where there is a tumor, there only nanoparticle will go and treat it. Nanomedicine. Similarly, in the case of agriculture also, when there is a pests and these things are happening, instead of spreading the fertilizer pests and throughout the chemicals spreading throughout the plants and the gardening and all these things, to the limited area, limited zone where there is some damage, we can use these nanomaterials. As nanotechnology can be used to enhance the environmental sustainability of the process producing negative externalities. It involves use of the products of nanotechnology to enhance sustainability. It includes making green nanoproducts, supporting the sustainability, minimizing the potential environmental and human health risks, use of NT products to existing products that are more environmentally friendly. These are some of the materials used in the agriculture. As our topic is agricultural industry sustainability, nano fertilizers for balanced crop nutrition, crop improvement, plant protection, nano sensors, weed management, nano pesticides, nano fertilizers, post harvest technology, seed technology, water management, soil management, plant growth regulators, and food technology. So these are the areas where today we are using in the agricultural field that has come from the nanotechnology in the form of various products. These are the potential applications of nanomaterials for sustainable agricultural production. In the form of fertilizers, pesticides, we are using nanoparticles, nanobiotechnology for target genic engineering, biomolecule delivery, nucleic and acid delivery in the form of DNA, RNA, monitoring physiological responses, environmental sensing. And in the form of nano agrochemicals for optimum dose as nutrition, balanced nutrient supply of proper nitrogen, phosphorus, zinc, and quality improvement, regulation of nutrient migration to environment, reduction of cost of the production, and ultimately protection with higher efficiency, easy handling. Nanoparticles in the organic and inorganic nanoparticles, we are all familiar with, because most of the people, most of us are from the farmers family background, agricultural background. Organic farming we are missing. So that is where we use the compost, that is the manure obtained from the cow dung and others, that is missing, and of course in certain areas this is again re-implemented. So nanoparticles of organic and inorganic nanoparticles which are using for this plant growth simulation, all these things. And these are some of the nano-based products in the form of nano fertilizers. Nano fertilizers involves the materials which are modified at the nanoscale. They includes nano zinc, titanium oxide, silicon, and iron. Now, these are nothing new. These are used by the farmers, in local farmers in our Andhra Pradesh and Telangana districts are also some of the local farmers are using these nano fertilizers throughout the country also. The cost is also less. The Indian government also has taken an initiative to produce these nano fertilizers. But of course, the environmental impact is to be scientifically investigated. Now, these are applied into the soil. Generally, these nano fertilizers are applied to the soil as a surface application to improve the fertility at the surface level of the various layers of the earth, and while mixing with water. And majority of these fertilizers become unavailable to plants as they are lost as rough of leaching, resulting in pollution. Conventional fertilizers, what we are using so far, urea and all these things, the conventional fertilizers, they are unavailable to the plants and they are lost as a runoff, leaching, resulting in pollution. This indicates technological need for the development of smart fertilizers. We are calling to Today, agriculture also industry 4. Today, we have agriculture 4.0. That is smart agriculture, smart manufacturing. Today, farmers are not interested to take risk of this availability of the coolies. They want in less time they want to spreading of these fertilizers and pesticides and all these things. In less time they want. So smart fertilizers or nano fertilizers. The nanomaterial based formulations are remarkable due to high surface area, higher solubility, ability to induce systemic activity because of its smaller particle size. Different types of slow release fertilizers and controlled release fertilizers have been generated with synthetic or biopolymers. So that is the fertilizers which we are applying today in the form of nano. They are capable of releasing their content slowly such that they will not damage as a major one. And most of the nano fertilizers are encapsulated. That is, nanoparticles are concealed or encapsulated in the conventional fertilizers, what we see nano urea and others, just like globules or particles. These particles, nanoparticles are encapsulated inside them, and they are used in the form of nano fertilizers. Then they release slowly to the plants or the trees, and it has been, of course, the adverse effects are also less. There are so many evidences, literature also. I have gone through so many scientific papers. So a practical problem faced during this pesticide application in the field is settlement of these components, spray tank and clogging. You know, generally farmers used to spray the fertilizers with the help of this spray tank, but a certain amount of the pesticide is also deposited on these tank walls. But that problem is not with the nano fertilizers or nano pesticides while spraying. The titanium oxide nanoparticles application in soybean has been described to result in drastic enhancement of the chlorophyll content. So increased growth, zinc oxide nanoparticle application has been shown to promote seed germination, seedling vigor and early flowering, and higher leafy chlorophyll content and increased stem and root growth in peanuts. So these indicate that the promises of nano-based methods for the improvement of crop productivity. Silicon nanoparticles were also found to support plant growth under various abiotic and biotic stresses. At the same time, titanium oxide nanoparticles have been shown to influence seed germination of tomato with significant improvement in mean germination time, seed germination index, seed vigor index, and seedling fresh white and dry fruit. The carbon nanomaterials have been reported to influence the plant growth and development by increasing the root length, seed germination and biomass production. So these are the some of the commercial products available from the nanotechnology for the agricultural area. So these are certain trademarks are also you can see here. So there are nano grow trademark, nano green, master nano ketozone, organic fertilizers, tag nano, NPK, phosphorus, zinc, calcium, etc. And biozar nano fertilizer and nano max NPK fertilizers, etc. We can see these are some of the commercial products available and they are being implemented and used in the agricultural sector. But the effects has been to be scientifically studied. The nitrogen availability with these things are also, you can see from this literature, nitrogen, potassium and calcium content by using these nanomaterial related fertilizers and products, and certain toxicity symptoms and deficiency symptoms are also studied. And of course, these are the various properties, the nanofertilizers that makes them advantageous and compared with the conventional fertilizers, more efficient application, improved biointeraction, environment footprint, reduced losses, higher efficacy, social acceptance, economic viability, scalability. You see, these are some of the pictures I have taken from our Acharya N.G. Ranga Agricultural University in Tirupati in the form of Karshaka farmer related videos. They are available in YouTube, and they show that these are the feedback taken from the local farmers. The crop yield, as you see in this diagram, the dark greenness of these plants and greens output, and of this papaya, chilies, and the cotton, the rice and the paddy, and all these things were also increasing within less time with good yield All these things were possible with the nano fertilizer spraying. These pictures I have taken from their report, and these are the some of the some I have shown only few. Nano gold, it's a nano fertilizer available in the market. Local farmers, many of the farmers are also using. They are getting a very high yield also, and that is IFCO nano copper, IFCO nano zinc, nano nitrogen, and all these things. In 2019, Indian government has arranged this seminar, FAI annual seminar, where we are seeing in this year some central minister, D.V. Sadananda, was advocating or guiding the importance of using of these nano products in the agricultural sector. This shows that more impetus on the use of this nanotechnology in the agriculture. Nanopesticides, insects, pests cause severe problems in agricultural fields today. Not only today, we see that. So nanotechnology can have a key role in the reduction of these insect pests and cause host pathogens. The expanding developments in nano-encapsulated pesticide formulations have been demonstrated to have slow-releasing properties. So nanopesticides will release the chemicals slowly onto these plants or gardens or the trees and all these things. So this is with these nano pesticides enhance its solubility, specificity, and permeability and stability. These nano encapsulated pesticide formulation demand a reduced dosage of pesticides and hence human exposure, and the resulting issue are a minimal, which make it to be environmental friendly. Of course, these are the carrier systems where we can apply certain nano pesticides and herbicides. They will act as the carriers, just like the drug carriers. They will act as the nano pesticide carriers. So they contain particles of pesticidal active ingredients or engineered structures with useful pesticidal properties. The objectives of nano formulations are generally the same as that of other pesticide formulations. Now, chemical industries, pharmaceutical industries, chemical industries, which make these nanopesticides, they are usually following the conventional techniques, but where the nanoparticles are encapsulated in the conventional urea and other agricultural products. These include enhancement of the solubility of the poorly soluble active components. Similarly, there are so many other areas, but I have taken only some of them due to limited time. That is nano fertilizers and nano pesticides and nano sensors. So these are the smart sensors as we are talking about smart technology, smart manufacturing. So which are developed by nanotechnology are powerful tools to track, detect, and control pathogens in plants and animals. So in the form of nanosensors. The sensitivity and performance of these biosensors can be improved by using the nanomaterial and also through new signal transduction technology. Today, the sensors equipped in the drones, remoteless piloted vehicles, and other air-operated aircraft and other related vehicles, they are using these GPS advanced sensors, nanosensors to track the agricultural sector, the condition of the agricultural sector. Many nanotechnology-based biosensors are at various stages of its development now. This is due to the development of the methods for the modifications of tools and procedures to fabricate, measure, and image nanoscale materials. Some of the nanomaterials such as nanoparticles, carbon nanotubes, magnetic nanoparticles, metals, cobalt, gold, silver, and quantum dots have been actively demonstrated for their applications in biosensors. The integration of chemical, physical, and biological devices to work together as a nanoscale sensor has promising potential to detect a small amount of chemical contaminants. So there's a nanotechnology enabled devices and its linkage to GPS will enable real-time monitoring of agricultural production. So that is about nanotechnology in agricultural sustainability. Now, but today agriculture, of course in India also, but in some of the advanced countries, European countries, agriculture has become use of the technology in agriculture is increasing using this advanced technology. That is how we call it as today the precision agriculture, or it is also called as agriculture 4.0. We are talking about industry 4.0, so it is agriculture 4.0. We see the beauty of these various nanotechnology products where from roots to the plants, because nanoparticles are very smaller in size, they can easily go through the cell walls. The plant which contain leaf and the barks, roots, and all these things. So nanoparticles can goes through all the cell walls easily. That is how from the root to the top of the tree, the particles can go easily. So for foliar application, soil application, nano fertilizers, biosensors, pesticide remediation. So it is possible because the nanoparticle size is very, very less. When we are using them in the form of fertilizers and sensors and pesticides, the passage, they can easily move from one part of the tree or a plant or even the crop from one location to the other location because of their smaller size, just like the blood flows in our blood vessels. Similarly, nanoparticles will easily go through the cell walls because of their less size. So of course, nanotechnology can be used in plant growth and even crop protection also. Once the farming has reached to the crop yielding stage, where actual measurement is needed, protection. Now, ultimate final stage has come, but crop must be protected. So in this area also, nanotechnology can be efficiently used. So in the last 2 decades, significant amount of research is going on in this area. Fertilizer application plays a pivotal role. Sustainable agriculture entails minimum use of agrochemicals. So these are the areas where nanotechnology can be used for crop improvement. Not only in the initial seed soil growing, but after getting the crop, these are the various areas where nanotechnology can be used in the form of various products and materials. That is crop protection, precision farming, stress tolerance, soil enhancement, using various nanoparticles and drought and degraded soil, healthy soil, germination, plant growth, and crop yield, and these things you can see here. Of course, these are some of the nanoparticles used in plant protection. That is the health point of the plant. Nano diagnostic, nano pesticides. These are some of the areas. And you can see some of the application of these nanomaterials in the form of multi-walled carbon nanotubes. So the crop species, the glycine max. So mode of application is seed priming. Concentration are 100 micrograms per milliliter. Duration of treatment is 24 hours. And response are enhanced germination and growth of seedlings. Zinc oxide nanoparticles, enhanced growth, biomass accumulation, and net photosynthesis. So in this, the species of the crop. And similarly, zinc oxide in other areas, and iron sulfide, copper oxide. So improved photosynthesis and biomass production in these plant species. The potential application of engineered nanomaterials in agriculture is also ascertained in disease and weed management. Now we all know the plants, and when they get certain diseases and proper management of the weed, unless we know proper management of the weed, entire crop also get damaged. So in this area, some of the nanoparticles in the form of these nanoproducts are zinc oxide, copper, silicon dioxide, titanium oxide, calcium oxide, magnesium oxide, and these things are used. So these are the some of the areas where we can apply. Now these are some of the areas. Now you can see here this one simple picture. So right from the roots, which nanoparticle can be used here? Zinc nano fertilizers. They start from the roots. They are going for improving the strength of the roots. And potash fertilizers and polycrystallamide nanoparticles can be used for improving the strength of the roots. Nanoporous zeolite and similarly ketosone nanoparticles, kaolin nanoparticles, and similar iron chelated nanoorganic particles. They are improving the health strength of the plant in the subsurface level below the soil. And similarly, other nanomaterials are nanoparticles at the leaf level, bark level, and the other areas you can see here. These are the polymeric nanoparticles, dendrimers, surfactants, metal nanoparticles, polymers, multi-walled carbon nanoparticles, silicon nanoparticles. These are some of these nutrients supplied by these nanoparticles, that is nitrogen, phosphorus, magnesium, calcium, sodium, potassium, in the form of these fertilizers. These are the various applications, of course, these things. Now,